All right. Welcome back, and today's lesson is about financial maths. We are focusing on a paper that was written in Gauteng in November 2023. And this paper particularly questioned three things. Number one, it wanted to see if students knew how to calculate depreciation using the reducing balance method. Number two, it wanted to know whether students knew how to use compound interest and under changing periods, right? Is a person use the student's ability to use the changing period, what you call it, method. And then last but not least, it was also checking simple interest versus compound interest when you are provided with the same principal and under the very same time period, but you are given different what interest rates. All right, so that's what the paper was. These were the three main focus of the paper. Let's begin now. 5.1, we're told that after 2 years a phone is worth a third of its original value. Use the reducing balance method to calculate the annual rate of depreciation of the phone. So observe, we are not given any particular amount, but what are the key things that we need to observe here? We are told that after 2 years, then the phone is going to be worth a third. So this is the amount in the future after what you call it, depreciation has occurred, right? And then we are supposed to use the reducing balance method. Very, very important. And then what were we looking for? What we are looking for is the rate of depreciation, right? So in this particular instance, this is the formula that we're going to use. So this is the formula that we use for what? For reducing balance method. Now, this A here, it means what do you call it? The present value. How is it the present value? Basically, what happens is this. I bought this calculator 2 years ago. When I bought it 2 years ago, right, let's say it was with 800 rands, right? Because it's not your normal high school calculator. So let's say I bought it for 800 rands. Now, 2 years later on, will it still be worth the same amount? The answer is no. It would have depreciated. Why? Because as you can see, through use, right, through usage and through wear and tear, the value will reduce. So the present value in the future, the present value, it's the reduced value. The reduced what? Value of an asset. Reduced value of an asset, right? So that's what this A represents. Then the P, right, it now represents what do you call it? So maybe here I confused. I'm not supposed to say present value. I'm supposed to just say that the reduced value in the future. Then the P represents the present value. What is the present value? Then it means to say that when I bought the calculator 2 years ago, how much was it worth, right? And then the I, obviously, it represents the interest rate. And then the N, it now represents the period or time. So if we go back to the question that we were given, it says after 2 years, a phone is worth a third. So meaning to say that the reduced value 2 years later on, it's a third, right? But we don't just write a third. Why? Do we know when it was bought the value? We do not know. And what do we do in algebra? What we do not know, we use letters. So we'll say that, oh, in that particular case, that here, this present value is equals to X. And then the reduced value is equals to a third, right? So which means that here, this third is a third. X is equals to, the present value is equals to X, open bracket, 1 minus. The interest rate, we were told is, remember, that's what we are looking for. We are looking for the interest rate. So we write I here, and then we close the bracket. And then the period is 2 years. So we say to the power 2, right? So the first order of business, what am I going to do? Now, I have to now say that since X is multiplying with this bracket and to the power 2, it means that we do the opposite. The opposite of multiplication is division. So in other words, we are now going to say 1 over 3x divided by x over 1, which is equals to, and since we have divided here, it means that here we also divide by x. So here now we're left with 1 minus I to the power 2. And remember, the KCF method, if you are having 1 over 3, now what can I say? This 1 times x gives me x, so I'm going to replace this one and place x here, and then I change the division sign, it gives me a multiplication sign, and then I have to flip, right, which means that I now write 1 over x is equal to open bracket 1 minus I close bracket to the power 2. Now observe, this x cancels out with that x, and then when I say 1 times 1, because here what's left is 1, so now I've got 1 over 3, which is equals to open bracket 1 minus I close bracket to the power 2. Now since I've got a squared here, in order for me to get rid of a squared, I must use a square root, so I use a square root here, and what I've done on the right hand side I should do on the left hand side. Now this square root button cancels out with the squared, and then now what do we have? We now have square root of a third, which is equals to 1 minus I, because this has cancelled out that, so we've got 1 minus I, but this one is a like term, so we're going to transpose this square root of a third, and then we are going to transpose this negative I so that it can be a positive. So we now say that I is equals to 1 minus square root of a third. I is equal to, right? So what are we going to do? Now I come here on the calculator, and then I now say that 1 minus square root of 1 over 3, which is equal to what? Which is now equal to that number, which is 0.4222, and a lot of what? A lot of numbers. But when I want the interest rate, I want it as a percentage, I don't want it as a decimal, right? So here I come and I say multiplied by 100. So meaning to say that the answer that I have on the screen, I have to multiply it by 100. So I come here and then I go ahead and multiply by 100, which is equals to 42,264. But now remember, on this particular question, on question 5, they didn't tell you the number of decimals to round off to. So in that case, the first instruction that you get on the first page prevails, meaning to say that you were told that you must round off to 2 decimal places. So when I look at the third decimal number, I've got 4, and 4 is equivalent to 4, it's not above 4, which means that the second decimal number 6 does not change. So now the final answer is 42.26%. that is the interest, the rate of depreciation. So the phone reduced its value by 42.26% per annum. This is the answer, right? Now we go to question 5.2, where it says that Cow's car wash is saving for new equipment. Cow invests 10,000 rands at 7.5% per annum compounded monthly. So, okay, 5.2.1, it says calculate the effective interest rate. So this is the key question, effective interest rate. So what do we do? So the first thing that we do is to say that we write this formula, which we use when you're looking for the effective interest rate or when we're looking for the nominal interest rate. What is the difference between the two? Now, what we have been provided in the exam, we were told that the interest rate is 7.5% and it is compounded monthly. It is compounded monthly. So that 7.5, that's what we call nominal interest rate, because it will have different compounding periods. Whereas with the effective interest rate, it's an interest rate which is per annum. It doesn't get to change. So now let's go ahead and we say that we are looking for 1 plus IEFF, which is equals to 1 plus the nominal. We now say 0.075, because they said 7.5%. And how do I get this decimal? You go to your calculator, you say 7.5 over 100, it will give you this decimal. All over, we have been told that it's compounding. This N means compounding period. It's compounding on a monthly basis, so we divide by 12 here. So we just do this. We place it inside the bracket so that our life can become easier in terms of doing the calculations. Now, observe, this is 1, these are numbers, which means to say that these are like terms. So now here I write that I EFF is equal to open bracket 1 plus 0,075 all over 12. This was a positive. When I transpose it, it becomes a negative, right? Then I say whatever I'm going to get here, I want it as a percentage. So whatever the answer is going to be here, I have to multiply by 100, such that when I now say therefore IEFF is equal to, then I'll be writing the final percentage, right? So when I come here, now I say that open bracket 1 plus 0,075 over 12 to the power what? Oh, I forgot to say to the power 12, right? Here, they should be to the power 12 because it's going to compound 12 times, right? Minus 1. So minus what? Minus 1 is equal to, I get 0,07 and 0,077 what? And then remember I said you must multiply by 100. So immediately I multiply by 100, which is now equal to, it now gives me 7,76. I'm rounding it off to 2 decimal places. So when I round it off to 2 decimal places, it remains as 7,76%, because 3 is less than 4. So 7,76%. And if you observe, remember, the effective interest rate is slightly bigger than the nominal interest rate, which was 7,5, right? All right. Okay. So let's go to the next question. All right. So on this particular question 5.2.2, it states that cow deposited 10,000 rands, that is the 10,000 rands which we were told earlier on here. At the end of the first year, the interest rate changes to 7.8%. Very, very key. It's changing to 7.8%. It's changing from what? Remember, we're told that it was compounding at 7.5% per annum, compounded monthly. Now when it's changing from 7.5 to 7.8. But that's not the only thing. The compounding period is also changed. It has changed from monthly to quarterly, meaning to say that after every 3 months. Let's continue. We are told that 6 months later, cow deposited a further 5,000 rands, which is an additional deposit. If cow requires sufficient funds for this, if cow requires 17,000 rands for the new equipment, will he have sufficient funds for this purchase after 3 years? So 3 years is the period, right? So let's go on the other side and then we perform the calculation. All right, so in this particular case, we now have what we call, this is a timeline, right? So T0, it is immediate deposit. T1, it means the first official. This is the first year, second year, and third year. So what were we told? We were told that between T0 to T1, which is the first year here, between T0 and T1 here, the interest rate is 7.5%. And the amount which was invested from T0 to T1, let's not forget that it was 10,000 rands which was spent, right? Then we are now told that from T1, maybe they're too close to each other, from T1 to T2 to T3 here, from this compounding period to that compounding period. Now, what has changed? The interest rate, it has changed to 7.8%. And now, what else changed? It's now compounding quarterly, which means divided by 4. And this 7.5, which we spoke about earlier on, it was 7.5 compounding after every month, which was divided by 12. So this is our interest rate. Now, if we go back to the particular question that we had, we are told that 6 months after the beginning of this 7.8, meaning to say that in year number, a year and a half somewhere here, a year and a half somewhere there. What did cow do? Cow made a further deposit of 5,000 rands, which means that here there is a 5,000 rands. So we want to know, will cow have 17,000 rands after 3 years? Nothing else has changed. So this is how we deal with this particular scenario. What do? We now start to say that let's consider this 10,000 rands here. So we say A is equal to the, let's start with the formula. A is equals to P, open bracket, 1 plus, what do you call it? I, close bracket to the power N. So A is equals to P is for the principal. The principal which was deposited is 10,000 rands. 1 plus I, which is the interest rate, the 7.5. So we say 0.075 all over 12 because it was compounding per month. And then we close the bracket and it compounded for 1 year. So we should be to the power 12, right? But then from year number 2 to year number 3, then what changed? What changed was now the compounding period, which means that these 10,000 rands, we now come here, we are going to talk about this interest based on this 10,000 rand principle. So now we say, open bracket, 1 plus 0.078, right, all over 4, because it was now, the 7.8% was compounding on a quarterly basis, right? Close the bracket. Now, when it comes to this particular compounding period, right, remember what happens now. It's 2 years. Remember, we're told that we are investigating 3 years, and already the first year here, so we say -1, which means we have got 2 years remaining, right? So we come here and we say 2, but we are going to multiply these 2 years by what? By the quarterly, because for the next 2 years there are 4 quarters whereby it will compound by. So we multiply by 4 here. So when it comes to this whereby you have having multiple, what do you call it, compounding periods, you say the year is multiplied by the compounding period. So 2 times 4 here gives us what? 8. So now I remove the 2 times 4 and I say to the power 8. Now this is the first step, right? We have dealt with the 10,000 rands, but remember, after a year and a half here, cow made an additional deposit of 5,000 rands. So here now we come and we say plus 5,000 rands. But the 5,000 rands, it never compounded on a monthly basis. It falls under this period of 7.8% divided by 4. So we say 1 plus 0.078 divided by 4, close bracket. Now, what's happening? A year and a half means 1 year, 6 months. And remember, what happens with 1 year, 6 months? This is equals to 18 months. Right? And 3 years is equals to what? If we say 12 multiplied by 3, that is equals to 36. So a year and a half, it means 1 year and a half. And half of 36 is what? We say 36 divided by 2, which is equals to 18. Right? So by the time cow made the deposit, 18 months had already passed, which means that 18 months were now remaining. Right? So what does that mean? It means that this was now 2 more payments, because in 6 months, remember we said a quarter in a year, it's what? Every 3 months. So there were these 6 months, it has got 2 payments, and a year it has got what? 4 payments. So we've got 4 plus what? 4 plus 2 here, which is equals to 6. So it's 6 payments, which this 5,000 rands, it compounded 6 times based on the quarterly. A year, he has got 4. It compounded 4 times in a year, and the remaining 2 years in the first year, when the additional investment of 5,000 was made, there were 2 compounding periods left. So when we write our exponent, we write to the power what? To the power 6. Now that we have done that, what do? We now go to our calculator, right? So when we go to our calculator now, we say we have got 10,000 rands, 1, 2, 3, right? Open bracket, 1 plus 0,075 divided by 12 close bracket to the power what? To the power 12, right? And then we go for the second compounding period. We say open bracket 1 plus 0,078 compounding on a quarterly basis, close bracket to the power 8. Then we add the additional 5,000, the further deposit which was made of 5,000. Then we now multiply it. We say multiplied by 1 plus 0,078 divided by the compounding period, which is quarterly, divided by 4. And then we close the bracket. We say to the power 6. And then we say is equal to, it gives us what? It gives us 18,191 rands and 0.03 cents. So we say it is equal to, therefore A is equal to 18,191 and 3 cents. Now the question was asking, remember, will cow have enough money to replace his new equipment? How much is it? 17,000 is needed. But actually cow made more than 17,000. He got 18,191 rands 3 cents. So you then answer, yes, you will have sufficient funds. Yes, you will have sufficient funds. And just like that, you have answered the question, right? So let's go to the next question. All right, the last question, which is 5.3, states that two friends receive an amount of 6,000 rand each, all right, to invest for a period of 5 years. So we've got two people who have received 6,000 rand each, and they're going to save it for 5 years. They invest the money as follows. We've got Mervyn, who invests 8.5% per annum, simple interest. Very key. The method of interest is simple interest. At the end of 5 years, Mervyn will receive a bonus of 5% of the principal amount. So not only does Mervyn benefit from the simple interest of 8.5%, he is also going to benefit from what? He's going to receive a bonus of 5% of the principal amount. The principal amount being 6,000. That is Mervyn. So let's first calculate how much Mervyn will get, or let's just hear the other part. They say that Haley, right, invests 8% per annum compounded what? On a quarterly basis, which is the compound interest. Who will have a larger investment after 5 years? Justify your answer with calculations. So we were going to start with Mervyn. We will calculate Mervyn using the simple interest formula. From there we will calculate what? Haley, using the compound interest formula, which has got compounding period of quarterly. The difference here is that Mervyn has got 8.5% when using simple interest, and Haley has got 8% per annum, right? So let's see who will get more money. So this is the formula for simple interest. P, the principal, so which is 6,000 rands, 1 plus the interest rate is 8.5%, which is 0,085, and then the N is the time period. Remember, we're told that they've invested for 5 years, and we're investigating between Mervyn and Haley who has made a better investment, who is smarter when it comes to money. So now we go to our calculator and we say 6,000 open bracket 1 plus 0,085 multiplied by the 5 years, and then we close the bracket, which is equals to, he makes 8,550. So this gives us 8,550. Sorry. Okay, but let's not forget, we were told that Mervyn gets a bonus. So now let's calculate the bonus. A bonus of how much? A bonus of 5%. 5% of what? 5% multiplied by the principal, which is 6,000 that he invested, right, is equal to. So we must find the bonus. So I can come here and say that 5, I press shift and then I press the open bracket here, that's where the percentage is, multiplied by what? Multiplied by 6,000, 1, 2, 3, which is equals to 300 rands. So the bonus which Mervyn gets is 300 rands. Now his total money that he has invested, it's now what? We now say that the 8,550 plus the 300 rands, which now gives us 8,850. 8,850. This is Mervyn's share, right? Now let's go to Haley. Now this is Haley. Now the method which is going to be used for compound interest is A is equals to P open bracket 1 plus I close bracket to the power N, right? So we now say A is equal to the principal is still the same, 6,000 rands, open bracket 1 plus what has changed, the interest rate 8%, so 0.08, and then it is to the power 5. Haley is not getting any bonus. All right, now we say 6,000, 1, 2, 3, open bracket 1 plus 0.08 close bracket to the power 5, which is equals to what? So he gets 8,815. 8,815. Okay. Comma 97 cents. Oh, sorry about that. So which means that Mervyn is the one who made a better investment choice because he got 8,850 and Haley got 8,815.97 cents. And just like that, guess what happens? Then this is the end of the paper, right? So this is what I would like to suggest. If you found this video to be very helpful, please do consider subscribing. Also, go to the comment section. If there is a paper that you have tried and then it has given you some problems, send me the paper or send the question via the comment section. Like and share with your loved ones or your classmates. Till we meet on the next exam paper. Cheers.